appreciate that. Okay, so anyway, calculator. If you don't know how to clear it, if you're watching the video, clear that calculator, because over time people adjust graphs and tables, and that may have caused some confusion. We are working on quadratics. Okay, so let's take a look. There's some practice problems. I even have a hint for number 9 is an odd one. The 2 mile per hour value should be plugged in for x, so there you go. But anyway, this one has a CMHW. I have no idea what my due date. Maybe I do. Maybe I do have an idea. Boy, that's not a very straight. That's sad. I can't even live with that. That is not even okay. I'm just going to let the bottom of the box, which no longer exists because I whited it out, be my line. But let me check my lesson plans. Let me see if I have a due date for that. It definitely will not be this week because I think it's going to take us certainly 2, but possibly 3 days of notes to go through this one. College Bridge Day in there somewhere, and if you are done with your College Bridge, you might get a chance to work on this during that time. Okay? So there definitely will be a College Bridge Day before Friday of next week. So let's get started. And what do you know about quadratics? I've asked you this question previously, about a week ago, and got some decent answers in different classes. Okay, once again, Jerry, nonverbal communication, has drawn a parabola in the air. All right. Is that what you were going to tell us, you know?
Yep.
What do their equations look like? How could you... Are you okay?
Yeah.
All right. Okay, so I said, what do their equations look like? We've got the answer square. They don't look like they're squares, but what do you mean by square?
Like x squared.
X is squared. The highest exponent in a quadratic equation is a square. So it's that square. That little bitty square takes a line and completely bends it out of shape. So let's see if we can figure out this. A blank function is a function in the standard form of... Oh, there we go. That's kind of a no-brainer, right? And I appreciate you actually speaking there. Yeah, he can if he must, right? A quadratic function is a function in the standard form of. So you know how lines have their y equals mx plus b? All right. What is the standard form for a quadratic?
Ax squared plus.
Okay, hold up just a second. Ax squared. Keep it going.
Plus bx.
Oh, you know what? I shouldn't be writing it right there. I'm sorry. I have a spot right here. F of x is equal to ax squared plus
bx.
Okay. Each of those 3 terms has a name, and I want you to know the names of the types of the terms because I'm going to use those names most likely. So I might refer to the this term or the that term. So the term that has the square, do you know what the name of that term is? It is the quadratic term. It's the term that makes it quadratic. So this is your quadratic term. All right? If that term were not there, it wouldn't be quadratic. If that weren't there, what type of an equation or function would we have? We would have a linear function, which brings us to this term, which is called the linear term. It's the whole term, the bx, is the linear term. And what do you think this little term is called? I'll give you a hint. It starts with the same letter that's named. It's the constant. So what does a constant look like? it's a number that does not have a variable. All right? So, it says A cannot be 0. What would have happened if A was 0?
Then the quadratic would be 0.
Yes, which means the quadratic term wouldn't be there, and this wouldn't be a quadratic function, would it? So if we had a 0 in front of that x squared, we wouldn't have an x squared, and we wouldn't have a quadratic, we'd have a linear equation. Without that, it's very similar to mx plus b. You have an x with a coefficient, and you have the b value, and the other one was a constant. This b has nothing to do with the letter b that's in y equals mx plus b. Because an mx plus b, that's actually a constant. All right? All right, so moving on, the common name for the graphical representation, what shapes are the graphs? What's it called?
The
Parabola. Now, in Algebra 2, you probably spent a bunch of time and energy working on quadratics. Are you like typing notes in the calculator over there?
No.
Okay, you focusing on my lesson here?
Yes.
Yes, you are. Okay, good. All right. Moving on. You've done a lot with quadratics, and there is a lot that can be done with quadratics, but in this class we will do just an overview. So whereas you may have spent 3-4 weeks of your life, maybe 6 whole weeks of your life in Algebra 2 dealing with quadratics, we're going to spend a few days. All right? So, our first thing, we're going to talk about some attributes. All right? That means some of the features that you would see in a quadratic in the graph. And so it says to use a graphing calculator to sketch the following graph. So generally when I tell you to sketch, it's a loose sketch, but we might use our table to get some really good points. So our first one, instead of saying y equals, they say f of x, so it's a function. We're going to put this into y equals, however, and we're punching in a negative 2x squared plus a 3x plus a 4. Did I get it typed in right? Looks good to me. So what do you think we need to do? If we've got something in y equals, in general, there's 2 things you might want to do with it.
Graph and table.
Yeah, we could look at the graph, and looking at the graph gives us a general idea, and you could loosely sketch that, but I'm thinking I may want to look at the table to get some actual points, but this gives me an idea of maybe I'm going to be looking at points maybe from around -2, +3, something along those lines. So to look at the table, I do second graph, and I think, I've got my table now set up going from -3. I'm not going to be graphing the -3 point, am I? I'm pretty sure this grid does not allow me to get to -23. It might have, do I have room to go left 2 and down 10 on this grid?
Yeah.
1, 2, 3, 4, 6, 7, 8, 9, 10. Barely. Okay. And I have room to graph the -1, -1. I have room to graph over 0 up 1, 2, 3, 4. Stretched a little higher than I expected. Wait. Yeah. Okay. And then over 1 up 5. And then as I keep going, let's see, I can go over 3 up 1, 2.
Or
Over 2, and over 3 down 1, 2, 3, 4, 5. But there are no other points that I can fix. Is one of those points the vertex?
Yes.
Actually, no.
Okay.
Okay? If you're eyeballing and kind of thinking, you might think, well, there's my highest point, that's my vertex. But you know what? If it was the vertex, then these points on each side would be exactly at the same height. And since, as I'm looking at my table, since it didn't give me the exact points on both sides, they didn't show me the vertex. So this is going to be a bit of a sketch. You don't see the vertex, and eventually I'm going to show you how you can force the calculator to give you that vertex. But if these numbers don't match on both sides, it's because your vertex is not at a pretty integer point. It's some funky decimal. All right? So I'm going to go back now to my sketch and go, maybe the vertex kind of was a little bit right above this. It's just kind of hard to tell. I'm going to do my best to curve through these points. I am just not exactly 100% sure where that vertex is. This looks pretty lumpy. So I'm thinking my vertex may have actually been a little to the left of that. I'm going to try to round it out. It's not a terrific sketch. I think it would have been a really not great sketch at all if I may not have looked at the points, or maybe those points kind of messed me up. But I'm just sketching it in general, okay? We are going to talk about some of the important features. Do you think in this mess here that I've actually gotten a great point for the vertex?
Somewhat.
Sorta? Okay. The vertex is somewhere around here.
175.
Okay? Your vertex is not that 0.15 though, is it?
0.75, and then my y is 5.13.
Okay, so it's not really pretty. So you do know how to get the calculator to give you the vertex, which is great because if you don't, we'll be maybe hitting that today. But just in general, vertex is either the maximum, meaning the highest point on your parabola, or it's the minimum. So do you think that vertex is the minimum point in that graph or the maximum point in that graph?
Maximum.
Okay, this case, it is a maximum because it's the highest point. I just, without doing further work, don't have it pegged exactly. There's a formula for finding the vertex. The calculator can go find the vertex as well. I just eyeballed it, okay? Another feature that, well, maybe we'll look at it in a, well, let's go ahead and look, okay? Here it says, label the vertex in each parabola above as maximum or minimum, and y'all agreed this one was a maximum, right? Do I have it perfect? Probably not. I'm just going to draw a big old point up there somewhere that I know somewhere around there I hit the highest point. Then it also says draw a dotted vertical line for the axis of symmetry. Have you heard that term before, axis of symmetry?
Yeah.
Okay. No? Have you ever heard of a line of symmetry? A line of symmetry is an imaginary line where you could fold a figure in half and the sides would match. Parabolas are symmetric. I'm going to have to eyeball my line of symmetry. I'm going to use my straight edge, and I'm going to go vertically. So what did you say it said the x value of the vertex was? 3/4 or 0.75? Okay, so it's a little bit to the left of that line going up and down. Okay, the axis of symmetry is a vertical line that goes through the vertex. All right, the equation of it is always going to be x equals whatever the x value of the vertex is. So this one, without showing you more stuff than I want to show you right now, we don't know the exact equation of it, except that Carson does know that it's x equals 0.75. Okay? All right, let's try this next one. Before we, well, let's see. No, let's go ahead and get the next one going. All right, so I'm going to go back to my graph. I'm going to remove the original parabola, and I'm going to type in the second one. With this 1/2, you can type it as the fraction numerator over denominator 1/2, but I get kind of lazy. I think I can more quickly type it as 1 divided by 2. It doesn't matter. Then I'm going to put x squared minus x minus 1. If I go to my table, it might give me decimals where your table might give you fractions if you entered it as the numerator over denominator. But first, let's just get a sketch of the graph. Y'all, why is this one opening up and the other one opening down?
The other one had a negative.
So the coefficient of your quadratic term is this a value. So what happens when that a is less than 0? First of all, what does it mean less than 0? What kind of numbers are less than 0? All right, so what happens if that leading coefficient is negative? Okay, well, so, but what does that mean? It means it opens downward. Well, this new one is not opening downward, is it? It's opening upward. I think I would like to see some points from the table so I don't just totally sketch this badly. So I'm going to go to the table. Let's see. Y'all look right here. Do you see that there is a certain point that above it and below it, the y values start pairing off and matching very nicely? That's my vertex. If I go over 1, now, does it look like negative 3/2 if you entered it as a fraction on your table? Okay,
Yeah.
I entered it as to me it's easier to graph a decimal than it is to graph a fraction, so you might want to keep that in mind if you have a fraction to enter. If you enter it as a division, it tries to give you decimals. So I kind of like that one. I've got the point over 1, and I can go down 1. I can eyeball 1.5 pretty clearly. Do you agree? Okay. And after that, the points on each side are symmetric. So if I go over to 0, I go down 1. But also if I go over to 2, I go down 1. All right? These are not whoppy-jawed. They are symmetric. So this must be my vertex because the points on each side are evenly spaced as you look at the y values. Okay. I can also go, what else I got? I got room to go from the origin left 1 up 1/2. And I can go over to 3 up 1/2. But there's room for more points, aren't there? Okay. I could go to -2 up 1, 2, 3. I could also, wake up calculator, I could go to +4 and go up 1, 2, 3. I think I can get another couple of points. If I go out to 5, I can go up 1, 2, 3, 4, 5, 6.5. So what did that look like? 13 halves for y'all? Okay. Or I could go to -3 and go up 1, 2, 3, 4, 5, 6.5. After that, it's at 11, and I would be beyond that top horizontal line. Do you think we got enough points to get a decent sketch? At this point, it's really not a sketch. At this point, it's plotting points, and we are just playing connected dots. So that's really not what sketching means, but I do get a pretty decent picture with it. As you graph your parabolas, here is what I'm picky about. So stop and pay attention. Make sure you curve through your vertex and don't make it a sharp V because it's not an absolute value graph. It's a curve. And then make sure whatever your highest point is, you go off the edge of the grid before you put arrows on the end. And I will take points off if you do not do that with the graph that has arrows on the end. I want to see those arrows beyond the grid that I gave you. All right? So that vertex would we call that vertex a maximum point or a minimum point? Tell me why.
Pointing downwards.
Not because it's pointing downward, because if I looked at this, I might say the graph is pointing upward.
The
But-
maximum is,
What does the word minimum mean?
Lowest.
Lowest. It's the lowest y value in this graph. So this vertex is a minimum point. This vertex is a maximum. As we look at applications where there are real life word problems that work themselves out to be quadratic, there will be a lowest possible value if it opens upward. There will be a highest possible y value if it opens downward. And frequently those are the answers to the questions. So maybe this is the path that a firework takes when it's shot up into the air and it comes back down, and I want to know the highest point. Maybe I am doing something in business and I'm trying to minimize my costs, and the vertex would be the minimum amount that I would try to achieve. Sorry.
is there any possible way a parabola can open sideways?
It can, but a couple of things happen. First of all, it won't be a function because you would have repeating x values. And if I wanted a parabola to open sideways, I would change the y, because this f of x is a y, and my variables are all x's. I would make this the x, and I would make these y's. Okay? But you couldn't put that in your graphing calculator because we don't have an x equals button on these calculators. This button is for graphing functions, and these calculators cannot graph things that are not functions.
So how
But you can trick your calculator into drawing a sideways quadratic by doing the inverse function. Since this function is squared, I could do a square root function. And you know how on the quadratic formula you have a plus and minus in that formula in front of the square root? Let me just, and this is not something y'all have to do, but I'm going to show you this. Let's say I do a positive square root, and now I can't put y in as a variable. So I'm just going to, I have to trick this in as a function, but I could put in a square root function like, I could just say the square root of x. And then that's only going to give me half of a parabola, the top half. But if I also graphed negative the square root of x, and then I looked at it, you'll see it'll draw it in two different pieces, but it will, so that's the one on top is a square root function, and that's a negative square root function, and together it looks like a sideways parabola. So, are we doing that? No, but I just thought you might think that was interesting because that was a really good question. In trig classes, sometimes you get into those when you are getting into what's called conic sections, which are, there's several shapes that are considered a conic section: a circle, an ellipse, which is an oval, a parabola, and also a hyperbola, which is almost looks like a parabola, but it's like a double parabola going outward. So you may have heard of hyperbolic curves or something. And anyway, that's a whole deeper section of math. And sometimes pre-cal classes get to those. Mine has not gotten there for years. We just don't get that far. All right, so anyway, I think we have done what this wanted. It wants me to label the vertex on each parabola as a maximum or minimum. Oh, let's draw the line of symmetry on this guy. So this guy, y'all, the line of symmetry or the axis of symmetry always goes through the vertex. And on this picture, my red pen, we actually know exactly which point is the vertex. Do y'all agree? Okay, so if I wanted the equation of the axis, and I'm just going to say equation of axis. Some math problems will say give the axis some will say give the axis of symmetry. They're talking about the same thing. This is a vertical line. A vertical line only has three things in its equation. First of all, which one of the axis on my grid did that vertical line cross through? Okay, it crossed X, so if you're making the equation of a vertical line, it has an X. Since it is an equation, it has an equal sign. And then it has the X value of where it crossed the axis, the X axis. Well, that's the same X value as this vertex. What did we say this vertex was located at?
1, -1.5.
Okay, 1, and I had it as -1.5, but if somebody else put it as -3/2, that's the same thing. So the equation of this axis is X equals negative, no, I don't go with the Y value. I go with the X value, X equals 1. Or in other words, this crosses the X axis at 1. And so if you ever need the equation of the axis, and I believe that maybe one of the things in your delta math is giving the axis of symmetry. It's a whole section that's something like, it might say attributes or features of parabolas or parts of parabolas, and each question asks you a different thing. It might ask for maximum or the minimum, but it may ask for the axis of symmetry. Well, that's an equation. X equals, give the X value of the vertex. All right, so let's put that right down here. The equation is X equals X value of vertex. So that might be handy for you to have as you are working on your delta math. There's a lot of little sections in that delta math. It's not just 5 sections, but you kind of can go through them fairly quickly. All right, let's flip the page. Are y'all all good? And let's continue this little adventure. You may. You do not even ever have to ask me. You can just get up and sharpen it. Okay, so on this page, I have got 6 steps that are the directions on graphing a parabola on your paper. So you might want to box off this whole section because you will be graphing quadratics. And there's a lot of instructions here, and I expect you to follow my instructions. All right? So let's go through what I am expecting you to do. Because, again, we're going to be graphing stuff. I think, and I may not have put it here. Let me go back and double check it. Oh, yeah, it says it right there. On your CMHW 5.3, it says, use the answer sheet provided to do this work because, like 5.1, there needs to be some graphs there. Okay? So when I am ready to get you started on that homework, I will give you a pre-printed worksheet with a space for all the problems to be worked. Got it? And wherever you need a graph, there's a graph. Okie dokie? All right. So the graph of f of x equals ax squared plus bx plus c can be graphed using these steps. Okay? So first of all, it says decide if the parabola opens up or down. How do you decide that? Okay. And where's this a coming from? Okay, it is this leading coefficient. What if there's not a number in front of the x squared? Okay, it's an understood 1. If they put a negative sign, we're understanding it to be a -1. If they put nothing, we understand it to be positive. If A is greater than 0, what kind of numbers are greater than 0?
1, 2,
So we can just group those all under the name of positive, right? So positive will open up, right? But if A is less than 0, it will open down if you have a negative. You'll hear me say the leading coefficient. But it's only leading if you make sure your x squared term is first. If these are all out of order, I would rewrite it in order with the quadratic term first, followed by the, what do we call this term? Linear, and the will be last. Okay? All right. Now, in this step number 2, I am going to give you a formula that will find the vertex. So, if you are looking at the equation, like we were looking at the equation on that very first example, and when we graphed it, we didn't see the vertex. You got the calculator to calculate the vertex for you, didn't you? There's also a mathematical formula to calculate the vertex if it's not obvious. So, does anybody happen to remember how to find the x value of a vertex using this format? Okay, I'm going to say it, and let me know if this sounds at all familiar. The opposite of B over 2A. Just that piece. Does that sound like something you just did that in Algebra 2? Okay? That finds the x value of your vertex. So if I'm asking for the vertex, I'm looking for an ordered pair, correct? So to find the x value, you do the opposite of B over 2A. Now, do you know why I'm calling that opposite and not saying negative B? Yeah, if it's already negative, somebody might think, oh, it's already negative. I just needed it to be negative. It already is negative. No. In a formula, a negative sign means opposite. So if it's already negative, if this term right here was negative, I would make it positive. If it's positive, I will put it in as a negative. All right? Now, that gets you the x value, but where are you going to get the y value?
maybe from the constant.
Actually, you've already gotten your x value, right? So now you know what x is. Isn't this an equation that has a bunch of x's in it?
Yeah.
And you know what x is by this time. So you're going to plug x into the equation. All right, so the vertex, the x value is the opposite of B over 2 times A. And then you do the math, and you get this number. Maybe it's a fraction, maybe it's a decimal, maybe it's a beautiful integer, but you've got this x value, correct? So how do you find your y value? Okay, so I'm going to say plug x in. Now, I just wrote plug x in. What are we plugging x into? The wall? The equation. Which equation? The equation on the math problem you're working on. Not rocket science, right? Now, we have calculators. This is like saying, hey, Fred, plug in this x value that I just found, and Fred's going to have this function that is a number times something squared plus a number times something plus another number. Make sure as you plug it in, you wrap it in parentheses in your calculator for safety's sake. Especially if it's negative, because if you don't use those parentheses, you're going to get a wrong answer. Okay? Now, that takes care of finding the vertex. All right? Now, you've already decided if the parabola was going to open up or down. So from that vertex, it's either going up or it's going down. So if it's going up, from that vertex is the minimum value. So if it's going up, you might want to jot this down. Here's your vertex. If it's opening upward, this is a minimum. Are you okay if I just write min? All right. So what would have to happen for a max?
Well, it would have to open downward.
The vertex would have to be at the top, the rest of the parabola goes below it, and that vertex would be a max. So you may be asked, does this parabola have a maximum or a minimum? Well, if it's written in this format, you can look right at the front and see whether it's negative or not and know if it's opening down or up. You can find the vertex by taking the opposite of your b value and dividing that by 2 times your a value. And how do you find the y value of the vertex once you've done that? Plug the x into the equation. All right. Now, the next thing it says is to determine the x-intercepts if they exist. Y'all, what are x-intercepts?
Where the y is 0.
Ah, okay. So x-intercepts, I'm going to peek at my notes a little bit and see if I have explained this better later. Okay, I think I'm going to make it happen right here. Okay, x-intercepts. Let me go with, let's try out this orange highlighter. Let's see how, oh, that's not too bad. X-intercepts. All right, so if I have a grid and I draw a parabola and I'm going to choose to make my vertex somewhere right around here, I'm just sketching out of the top of my head, and I'm going to make it open upward, because if I make it open downward, it's not going to hit the x-axis, is it? It's going to not have x-intercepts. That is where you would have run into imaginary numbers last year in Algebra 2. Okay, so I'm going to make this guy open upward, curving on the right side and the left side. So how many places did the parabola I just draw? How many places did it hit the x-axis?
2.
At 2 places, okay? So I can call those 2 points, I can call them the x-intercepts.
What about the inverse?
Okay, I can also call them the zeros, and there's a third name that they are sometimes called, roots.
Yeah.
So I believe on your matching, somewhere there is a definition that says another term for x-intercepts or zeros. Well, what 3 terms did I just give you?
Roots, x-intercepts, and zeros.
So maybe another term for x-intercepts and zeros would be roots. Oh, well, look, that's right there, number 15. Ah, so do you know why they're called zeros?
Because we were y is 0.
Okay, well, that has to do with how we can find them. If you don't have a picture, you can find the x-intercepts by substituting 0 for f of x. You know, what does f of x mean? So you could plug 0 in for your y and then solve for your x. That will find your x-intercept. Now, there could be none, okay? There could, if there's none, it's because you will not get an answer that exists. If you try plugging it in, it's not going to work out, all right? If there's 2, you will get 2 different ones, because quadratics expect 2 solutions, all right? If you get just 1, it's because your vertex is sitting right on the x-axis and only bumping into it in one place. Sometimes they call that a double root. All right. The next thing, that orange was a little darker than I wanted it to be. The next one, item number 4, is to determine the y-intercept. If you want the y-intercept, this time you substitute 0 for the x. Okay? And you plug it in the equation and you do the math. After that, you now have the vertex, so that's a point that you can graph, right? You have the intercepts, those are points you graph. Connect the points and sketch the graph. All right? You will also always have a calculator available that you could double check if you wanted to find other points. But if I give you a problem that provides you with a space that looks like this, I am expecting to see the scratch work that is described in these steps. And if you just go let the calculator find those things for you on a problem where I am asking you for all of this information, you're going to get a bunch of little X's on the paper because you didn't do the math that I wanted. Are you with me on that? So let's try out our 6 steps for this example. My function is f of x equals x squared plus 2x minus 8, and do not put this into y equals. We're not going to let the calculator tell you the stuff. We're going to let you use the steps. So step 1 tells us to do what?
Decide if the parabola opens up or down.
I've got a blank right here for it. How are we going to know if this parabola opens up or down?
It opens up.
Tell me why you know that.
There's no negatives.
Okay. So what is my A value if I don't see a number there?
Understood, positive 1.
Understood, positive 1. Positive 1 is positive. We are opening upward. So I know when I can get my parabola, I can get the vertex in place, I expect it to curve up from there, not down, right? Okay, now we move to step 2 to find the vertex. And what is the formula for finding the x value of the vertex?
Opposite of b over 2a.
Okay, I appreciate that you used the word opposite when you said that. And you guys, you are taking notes that you can follow. So I think it is very wise to go ahead and remind yourself what formula you're using right here. So if we look at this, here's my b value, right? What's my b value? 2. Do I use the constant in this formula? No, I don't. Okay, so what's the opposite of b?
-2.
Okay, and can you multiply 2 times your a value?
Yes.
What is 2 times 1?
2.
Can that divide nicely?
-1.
-2 divided by 2 is -1. If you need your calculator for that sort of scratch work, you can use it for that, for sure. So I'm about to write my vertex, so I'm going to start building an ordered pair to be my vertex, and I know the x value is -1. Now, for this next part, you may most definitely use your calculator, but you're not putting it into y equals. You are just going to be on the home screen. How do you get out of y equals and back to
Second
home?
mode.
Second mode, because right above mode is quit. That always takes you back home. Okay? So, my equation, tell me about, now right here, I say y equals. Right here, the function said f of x. So Fred's playing. What was Fred's rule today?
Something squared
Something squared
plus 2 times something
plus 2 times something.
-8.
And what am I going to plug in?
-1.
-1 and a -1. Now, you might be able to do this in your head faster than you can put it in the calculator. I know that -1 squared is a 1. I know 2 times -1 is a -2, followed by a -8. I'm getting a -9. I also know that so many of you have been super reliant on your calculator since they put them in front of you in 8th grade, and you don't even trust 2 times 2 anymore. Is that correct?
Yes.
So, if you don't trust anything, then let's check if the calculator agrees with me. Let's play a nice round of Is Mrs. Stewart Right? No. Let's play that round tomorrow. Okay, well, let's just do it real quick. plus 2 times negative 1
You would be
minus
correct.
A. Mrs. Stewart is right, and that is the Y value of my vertex, and that is where we start tomorrow. All right? Have a lovely rest of your Thursday. Yes, thank you for reminding me to stop the video. Oh, wait, you didn't, but thank myself for remembering.